Good morning, students. Today we are going to study about refraction of light. Refraction of light means bending of light when it moves from one medium to another. All of you must have seen this type of bending when you observe a pen or a pencil kept in a glass of water. This is an example of refraction. This is the interface of water and air where you can see this bending. So this is an example, a very observable example of refraction of light. In these two bowls you can see the water is there. Here the coin is outside, whereas it is now inside the bowl filled with water. Here the water is resulting in the raised level of coin. In the second you can see the arrow appears to be raised by water level. So all of you can try these experiments at home. These both experiments are usual or very observable examples of refraction of light. Now this is a very interesting example of refraction of light. You can see the arrow has changed its direction and appears to be bigger when we look at it through a glass of water. So this is due to repeated refractions, and it could be called as an optical illusion, because actually the arrow is kept moving from left to right, but when we look at it through a glass of water, it appears moving from right to left. Now in this slide, let us learn some terms associated with refraction. First, let us define refraction. Refraction is the bending of light that occurs when light enters from one media to another. So it has to move from one media to another. Now let us see what are they. Now I've drawn a line. This line separates two media, that is air and water. And again I draw this place. This place is the meeting point of both these media, and it will be called as air-water interface. This is the light or ray of light which is coming, and it is hitting the air-water interface, and as you know, it will be called as incident ray. Then this incident ray is hitting at a point. That point is present on air-water interface, and it will be called as point of incidence. This you have studied in class 8, right? Now, if there was no change of media, the incident ray would have continued in the same direction. But since there is a change of media, it will not go in the same direction. So it has been put in a dotted way, and we can label it as extension of the path of incident ray in absence of change of media. If there was no change of media, the incident ray would have continued in the same path. That is the meaning of this text. Now we'll draw this line which is perpendicular to the interface, and all of you must be knowing that it is called as normal. Since there is a change of media, the incident ray will change its path. There will be a deviation, and that deviated ray will be called as, yes, it will be called as refracted ray. So these are the normal terms that we come across when we are studying about refraction. Now let us reverse the situation and see. So now this is the boundary of again air and water. Yes, you can guess it. It is interface. But now I have written it as water and air interface. What is the reason? Because now the incident ray is coming from the water side. So it is crossing the water and it is going to air. So this is the incident ray, and you can locate this point. This point is point of incidence. And this is, yes, any guesses? It is the extension of path of incident ray in absence of change of media. If this was water only, if it was not air, it was water, the incident ray would have continued in the same path, right, without any deviation. But now let us see. This is a normal, so I have not written it again. You can see there is a deviation from the path. there is a bend. This is the normal path, and due to the change of media there is a bend. So this bent ray will be called as refracted ray. So I hope you are now used to the terms that we are going to come across when we are studying refraction. Now let us see what to the next level. Now again I have drawn the boundary of the media, the interface. What are the media? Air and water. And what is this ray? This is incident ray. And there is a normal to the interface. Now I have drawn an angle. So you can guess that this angle is angle of incidence from your previous knowledge. Again, this yellow line is the bent line. It has got deviated, and now it will be called as refracted ray. And it makes an angle with the normal. This angle will be called as angle of refraction. Let us reverse the situation and see. Yes, the boundary, the interface, the media and the interface, the incident ray, the normal, and now what is this ray? This is the refracted ray. Now incident ray and the normal, what kind of angle are they going to make? Keep a guess. Yes, now the refracted ray and the normal, they are making an angle. What is this angle? Let us find out. Yes, when the incident ray and the normal make an angle, it is called as angle of incidence. And this angle will be called as angle of refraction. Now when we combine all these things, we get some laws. These are called as laws of refraction. Let us know about them. Laws of refraction state that the incident ray, the refracted ray and the normal to the interface of two media at the point of incidence all lie in the same plane. So the incident ray, refracted ray, normal to the interface, okay, normal to the interface at the point of incidence all lie in the same plane. So if you are doing this experiment on a tabletop, all these four things, incident ray, refracted ray, normal and the point of incidence, everything you'll get on the same tabletop only. That is the meaning of this statement. Let us go to the next law. The next law is called as Snell's law of refraction. It is the ratio. Ratio means when you use it in the fraction form. Sine of angle of incidence. So sine I by sine R is a constant. You will always get a number here. Okay, it will be constant, and this value will be very specific for the pair of media. That is, for air and water it will have some value. For water and air it will have another value. So it depends on the media. Suppose I use glass here, then the value will change. Suppose I use diamond here, the value will change. And also the color of the light. Instead of using white light, if I use red light or green light, again the values will change. So that is the meaning of this sentence. Now let us put it in a mathematical equation. Sine I by sine R. So this means sine of angle of incidence. This means sine of angle of refraction. It will always remain a constant. We'll get a constant value. Now let us sum up what we have studied in the previous slide. Sine I by sine R, that is sine of angle of incidence to sine of angle of refraction. It is always a constant, and this constant is represented by a value or a symbol mu or n. Some people refer it as mu and some people call it as n. The name for this symbol is, or this value is, refractive index. Refractive index helps us to measure the amount of bending of light, how much it has deviated from its path. That is a measurement given by refractive index. Now for example, index of refraction of air is n is equal to 1 and for water it is 1.33. So if we put both these values for air and water, for air it will remain 1 and for water it will be 1.33. So this indicates that air and water, they will bend the light differently. So it will be different for every transparent medium. So I hope you have understood some concepts of refraction. Thank you so much. Stay healthy, stay safe.